All right, good morning, everyone. Thanks for being here. I'm going to be talking about ICS and OT asset inventory challenges and solutions. I'm from the Idaho National Laboratory. A quick introduction about me. So I'm Justin Wilson. I am the ICS ISSE at INL. That's the Industrial Control Systems Information Systems Security Engineer. This is one of the times I'm grateful for acronyms because that's a mouthful. And my primary focus at INL has been implementing an ICS and OT asset monitoring solution. And so I'll be talking about what we're doing at INL, what's been working for us. And so to start off, why is an ICS and OT specific asset inventory so important, and what makes that different from a more traditional IT-centric asset inventory? So as far as why it's important, so there are several frameworks where this is a strong or a core part of it. The CIS Critical Security Control number 1 is asset and inventory of all enterprise assets. Dragos lists visibility monitoring as their number 3 in their top 5. Industrial Defender lists that as their number 1. The NIST CSF framework, both the 1.0 and the new 2.0 that just came out, lists that as part of their identify core concept. There's the ISA 62443 lists control system component inventory as part of their framework. And of course, we've got some federal mandates now, like the M2404. There's an IoT inventory that specifically says that these kind of assets need to be inventoried, and we need to know what we've got on our networks when it comes to IoT and ICS and OT devices. So the idea behind this is you can't protect what you can't see. And that may be great marketing material, but it's also true. If you don't know that it's there, you can't make a plan around how to protect it. You can't incorporate that into your incident response plan. And so that really is true. All right, so a quick intro to industrial control systems for those who don't work with them on a daily basis. Industrial control systems are specialized computers that control industrial and cyber-physical processes. Examples of where you might find industrial control systems include power generation and distribution, water and wastewater management systems, traffic control systems, nuclear reactors, agriculture, manufacturing, baggage handling systems. We all use those on the way here. Oil and gas, railways, aviation, building control systems, and robotics. So pretty much all of the modern technology that makes our world go round and gives us the lifestyle that we have with water and electricity, that's all reliant on industrial control systems. So you'll be hearing me use the terms ICS and OT a lot today. For purposes of this conversation, I'll be using those terms interchangeably. Technically, there is a difference, but as you can see, there's not much that is OT that is not also ICS until you're getting more out into the weeds. So what do they look like? I like having this slide in there because I'm a very visual person. And again, if you're not working with industrial control systems on a daily basis, it can be kind of a nebulous topic. So this is a Siemens PLC, or programmable logic controller. This would be like the brains of a piece of equipment. Maybe some manufacturing equipment, maybe a generator or something like that. This is a Siemens brand HMI, or human machine interface. So this is what you would use for an operator to interact with equipment, to interact with a PLC. This is an Allerton building automation controller. There's a Carrier brand iView integrator, the Reliable Controls building controller. So all of these things have an Ethernet port on them, and you can plug them into a network. Yet you can tell just by looking at them that they're very non-standard, non-IT devices. You can't install antivirus on these things, you can't install asset inventory agents on these things, and so you have to take a very different approach when it comes to securing and managing these things. One of the challenges that we also face in the ICS and OT world is the industrial protocols. So you're not going to see a lot of normal like TCP IP, normal kind of IT type traffic coming from these. They use specialized industrial protocols, many of which are proprietary. These could include a Profinet, Ethernet IP, Modbus, BACnet, BACnet IP, DMP3, and about 500 other ones. And I've got a graphic on here. This is the breakdown of BACnet against the OSI model. And this, I think, is really interesting because you see in the data link layer, where you normally have your Ethernet frames, instead you've got this MSTP protocol and IP protocol, which is not normally found in layer 2, so that's interesting. Question here?
Are you trying to standardize on one, say like DMP3?
I'm not trying to standardize on anything. My job at INL is to monitor everything regardless of what protocol it speaks. So then in the network layer, layer 3, where IP protocol would normally be, we've got the SPACnet network layer, and then layers 4 through 7, SPACnet application layer. So that's an example of what an industrial protocol might look like. And because these protocols are so different, standard IT monitoring tools like NDR, network detection and response, are going to fail to adequately identify and classify this traffic and be able to alert on suspicious activity that's happening over these protocols. So I wanted to do a quick breakdown of what this looks like in Wireshark. So this is a BACnet IP packet captured from our network. There's just a couple interesting things that I wanted to point out again to illustrate the difference between IT and OT. The source and destination port are both the same. That's not something you would ever really see in the IT world, but it's extremely common in the OT world. The source network address is 6530. If you ask any network engineer about network addresses, they will tell you that it's not a valid network address, yet that is a very valid network address in BACnet. All right, so we can see this packet is it's a complex app, which means that multiple pieces of information are being returned as a result of a request that occurred. The request was read property multiple, and here we can see the data that's being returned. So in this case, we have the property identifier is present value, so we have a present value of 10 million something. And the second value that we have is has a data type of status flags, and then the value is FFFF. So as you can see, this is all very plain text, clear text. This is not encrypted at all, which means that this is also susceptible to machine in the middle attack by an attacker. It's trivial for an attacker to intercept this kind of traffic, change these values, and change what's being sent to or from a PLC, to or from an HMI. This is actually more or less how the Stuxnet attack happened. The PLC had been infected, they were spinning the centrifuges out of control, but normal data was being reported back to the control center. So when they're looking at the charts and graphs, they couldn't tell that anything was wrong. And that's because the Stuxnet was able to intercept this information and then feed back false data to the operators. So they didn't know that anything was going on. So there are a lot of asset inventory solutions that exist now. 10 years ago, that was not the case, but within the last decade, we've had a lot of these tools pop up. And these tools monitor network traffic to discover devices, protocols, and relationships between devices. And in addition to monitoring this network traffic passively, these platforms can also speak to these devices using native industrial protocols to get additional information about them. So it might speak to a PLC in Modbus and say, hey, what are you? And the PLC will respond back and tell you, it'll happily tell you everything about it. It'll tell you what it is because that's what it's programmed to do. And so we can use that from a cybersecurity and asset inventory perspective to gain additional information about these devices. All right, so again, passive is considered very safe. You can feed these tools a PCAP, you can feed them a tap or span port, and they'll analyze it, they'll extract devices from that, and build out an asset inventory for you. You get a lot of really good information really quickly this way. And it's very non-disruptive because you're not introducing new traffic into a system. And then with active queries or active scanning, like I said, these platforms can speak to devices in their native protocol and query more information from them and use that to enrich your asset inventory. So there is a slight risk of changing processes or affecting processes because you're now introducing new data into a network. But generally speaking, this is considered to be pretty safe. So to put this into meme form, so what passive saw and what active queries saw, they're seeing the same thing just with more data, the active queries. All right, so this is a screenshot from the tool that we are using right now. And I wanted to point out some of the really cool information that we're able to gather using this tool. So this first thing here is the state. And so what this means is a PLC will have a run state or a run mode. Like it might be in run mode, it might be in program mode, maintenance mode, what's another one? Like standby mode. And these modes do different things. If the PLC is in program mode, it's ready for a programmer to download new code to it. If it's in run mode, it's expected to be in production in normal operation. From a cybersecurity perspective, it's recommended to keep PLCs in run mode if you're not in the maintenance window. And the reason for that is because when a PLC is in run mode, there's a very limited number of changes that you can make to it. Operators sometimes like to keep PLCs in program mode because it means that they can make changes without leaving their desk. They don't have to go out to the plant floor and flip a switch on the PLC and plug into it. They can just send changes over the network from their desk. And so it's a time-saving thing for them, and it makes their lives easier. Unfortunately, that also makes it easier for attackers, because if they're able to compromise the network, then they can just download code to your PLC for you, and that's never a good situation to be in. We actually had something happen where code was accidentally sent to the wrong PLC, and it wasn't discovered until they found out that that equipment wasn't functioning as expected. And so by being able to monitor the run mode, and when that changes, we can actually receive alerts on this. If the run mode changes, we get an alert, and then we can go and investigate and figure out what's going on. All right, so we've got vendor, model name. It automatically assigns a criticality and risk score to it. We've got the PLC name and PLC firmware version number. And this is really valuable because if you've got the model and you've got the firmware version, you can now compare that against a list of vulnerabilities, a vulnerability database, and find out what vulnerabilities are likely to exist on this device based on the firmware version. And in this case, we've got some more backend information on this particular device. All right, so this is one more thing that you would never get from a traditional IT monitoring tool. So in OT, we have what's called a backplane. So basically, the PLC might be plugged into your network, but then it'll have a bunch of additional cards or modules attached to it. And they're all behind the same network interface, therefore they all have the same IP address. You can't really know anything about those devices. But with an ICS specific monitoring tool, you can talk to the PLC and say, hey, what's on your backplane? And it'll tell you. And so in this case, what we're looking at here is the back plane, and there's actually, we're only looking at a small portion of that. There's a whole bunch more devices here. But so each one of these vertical bars represents a different device, or different device on the back plane. So we're able to gather that information, and then at a glance see, again, what is this thing, who made it, what's the model number, what's the firmware version. So there's really a whole bunch of data that you can get by talking to these devices, using their native language, and pulling that information off of them. So this is a network map. You've probably all seen these before. But what I like about the way that this tool works is you'll notice some of these lines are darker. And those dark lines indicate that industrial protocols are in use. So if you click on one of those dark lines, here we can see there is BACnet being spoken between this 61 device and this VFD down here. And so this is really nice because at a glance you can see what devices are speaking to each other using industrial languages, and if there's something weird happening, like your domain controllers are speaking to each other in Modbus, you might want to look into that. Might be less than ideal. I just wanted to point out over here the protocol list. At a glance, by looking at this list, it's a really long list. You'll notice the size of this row bar. We can see that there's factory talk being used on our networks. There's BACnet. If we were to scroll down further, we'd see things like some Mitsubishi and Siemens protocols. And so you can see at a glance what protocols are being used and have an idea of what's going on your network. Is there a question?
What tool is this?
So this, I left it out because I assumed we were supposed to be vendor agnostic, but based on other talks, that seems to not be the case. So we are using Tenable OT, right? Tenable OT security. They do have a booth here if you want to go talk to them.
All of this is their interface, right? This is going from them.
Yes. All these screenshots are taken straight from Tenable OT. One of the cool bells and whistles this thing has is attack vector generation. So you can select a device, click generate attack vector, and it'll try to calculate the shortest route from an external network to that device. And so in this case, it looks like there's communication lines between an external network and this device over TCP 17778. And that device talks DNS to this DC1 device. And so conceivably, if an attacker were able to get in over those ports, they would be able to access that device. All right, so these are some of, you probably can't see this, these are some of the active queries that are available. Periodic snapshots, this is a cool one. So it can take snapshots of the code that's running on a PLC every 15 minutes, hour, day, whatever is appropriate for that, for your environment. And then alert when that changes. Because program changes on a PLC are pretty infrequent unless you're in an outage window. That's not something that should normally be happening. And so by monitoring that, you can detect potentially malicious behavior and know if someone's trying to upload a backdoor to your PLC, for instance. Controller discovery, that discovers new controllers on your network using these industrial protocols. Controller state query, that's what I was talking about with run mode, program mode, maintenance mode, etc. Controller details, that pulls the hardware and firmware details. And there's the backplane query, which gives you all those extra devices that are attached to the backplane. So our timeline for this, we started working on this in 2022. Got our initial rollout completed end of 2022. Basically, ever since then, we've been working on deploying additional sensors and adding additional tap traffic to this device so that we can continue to monitor additional networks, environments, and through the sensors get that active queryability in a larger number of locations. So many options exist. And of course the question is, well, which one should I buy? And I'm not here to tell you that, but I can point you to a really great talk that I attended in 2022 at the ICS Cybersecurity Conference in Atlanta. It's called A POC Methodology to Choose the Right OT Monitoring Tool. This is the most comprehensive framework or approach that I've ever seen to selecting an ICS OT asset monitoring tool. Highly recommend it. Out. It's on YouTube. You can scan the QR code. The TLDR version is define your requirements, know exactly what it is that you expect from these tools, test the tools on known inventory, and then score the tools based on accuracy and completeness. Now, something that I've learned through personal experience is that testing the tools on known inventory is important because what I found is that I'm getting all of this data from Tenable OT, and I assume it's correct, but I don't really know that because it's reported back thousands of devices, and for some of these, it's the first time that we ever even knew that these devices existed. And so I don't actually know what they are. I couldn't walk up to this device and read the model number on it. I can't know for sure what the firmware version number is. So I'm really trusting what this tool is telling me. And so what I would recommend is have some kind of a test lab, a test environment where you can test these as you're doing a proof of concept, where you know what the device is, you know what the firmware version is, you know everything about it, and then see if the tool is reporting back to you true and accurate information. A few other interesting resources that are out there. There's a project called ICS NPP. It's the Industrial Control Systems Network Protocol Parsers. It's a project that's been worked on by CISA as well as INL. It is available on GitHub. And what this is, it's a collection of Zeek protocol parsers for ICS protocols. And this can be integrated into an existing Zeek deployment. So if you don't currently have an ICS specific solution, or you lack the budget for one, you can play with these protocol parsers, add that to an existing Zeek deployment, and gain some additional visibility that way. Additionally, there's a project called Malcolm. This is one that was developed at INL. You can think of it as it's kind of like Security Onion, but geared towards ICS. It's got all those ICS protocol parsers built into it, and so that's something that you could play with as well. All right, are there any questions? Okay, I see one back here.
What were your pain points? I.e., Tenable OT, we're facing a big FUD factor trying to get it running. What do you wish you had been told when you first started deployment?
So the question is, what do I wish I knew before we started deploying Tenable OT? I would say I wish I had a better understanding of the recommended architecture. So what we found is we set up our one appliance, started feeding like 1.5 gigabits of traffic to it, and kind of overloaded it a few times in a few different ways. We found one that it was extremely slow to respond. And so we increased the 32 gigabytes of RAM to 64, rebooted it, and watched it slowly use up all 64 gigabytes of RAM. So then we increased it to 128 gigabytes of RAM, rebooted, watched it go up to 128 gigabytes of RAM, increased it to 256. Anyway, we found that on boot up, it gets up to about 192 gigabytes of RAM. And it eventually tapers back down to 64 or so. But I say that because I think the reason it's doing that is because we're feeding it way more data into a single instance than it was intended to handle. It's meant to have more of a distributed architecture. And if I had better understood that up front, then we could have distributed the workload a little bit more evenly. So yeah, the architecture was one of the pain points for us.
So when you said you sometimes have, you definitely found systems you didn't even know existed in the environment. How do you chase that down? Is that something where you have to go find the owner? Who owns this? How did you figure that out then? Who owns this? What is it doing?
Yeah, so the question is, we're finding all these new devices, how do we know who owns them? And that is a current struggle.
Still.
For sure. Some of it we're able, I mean, we have good relationships with a few departments. We started deploying this with our HVAC guys, and we kind of know their naming conventions, and so when we see the naming convention show up, we go, oh, that's probably these guys. Hey, do you know what this is? What do you know about it? On the airplane, on the way here, I was actually creating a document. Okay, how do I identify unknown devices? Because I was going through that struggle. And so I was coming up with all these things I could potentially investigate, and analyzing the host name is one of them. Look at what subnet it's on. Go look at your network diagram. Figure out who that subnet belongs to.
Gotcha. So it's an investigation. It's like
it is an
private
investigation. It
investigator.
really is. We just spent like 3 or 4 weeks tracking down one device to make a change to it.
Got it.
It's a struggle. It's not a problem that I've solved yet. It's a problem that I'm working on. And if there are any vendors in the room that have a solution for that, come and talk to me.
Yeah, so how important is like other tool integration with your exploration at INL? In other words, you're looking at deduping data that you see, you're trying to see the source of truth. Are you pulling in different data feeds from other tools and trying to corroborate what you're seeing there in the platform?
Yeah, great question. So as far as integrations go, what we're doing right now, so we use Axonius for our enterprise side asset inventory. That's our single source of truth when it comes to our inventory. And Tenable OT has an integration with Axonius. And so we've got that set up. It's an API integration where, like, 4 times a day, Axonius queries Tenable OT. It gets a massive JSON file of the entire inventory that is picked up. And then Axonius handles any kind of deduplication from that point. Any other questions?
Would you be willing to stay and be on our panel? We're gonna have a second. Rob and Doris. Yeah, you're good.
Okay, sure. Yeah, I can stick around.
Okay.
One more question?
So once you discover your assets, what's your experience been with remediation and mitigation of these type of devices?
Regarding discovered vulnerability specifically?
Yeah, like a lot of these things, they're not easily to mitigate or remediate. Maybe there's not a patch available, so you have to maybe tuck it in a corner behind a firewall interface or something like that. I mean, what's your general approach with protecting your vulnerable ICS devices?
Yeah, so in most cases, there's not really a realistic upgrade or patch path. And so it's firewalls, it's building a fence around it, looking at access controls, who has access to that system, should they have access to that system. At INL, we use a pretty restrictive approach to firewalls. It's basically you're denied access unless it's explicitly requested. And so that helps a ton, where people don't normally have access to things via the network unless they've explicitly requested access to it. And so because of that, access is already pretty restricted to most of these devices. But yeah, building a fence around it through a defense in depth would be the best way to do it.
One more follow-up question. So I imagine all your discoveries are mostly via Ethernet with your Tenable OT tool, right? But do you care about the serial connections and the other type of ICS connecting with other media, or is that a scope?
Yeah, so the question is, we look at like serial devices that don't have an Ethernet port. Currently, that has not been a heavy emphasis for us. Just gaining monitoring capability into the devices that have an Ethernet port is probably going to take another 7 or 8 years. And so we haven't gone down that rabbit hole yet. I understand, I heard in another talk, someone was using some serial to Ethernet adapters or something like that to kind of capture the serial traffic and forward it on via Ethernet. So there are some hardware solutions like that exist, but we haven't explored those ourselves yet.
Would you potentially see those, even though they're serially connecting to some other system, would you potentially still see them because then there's another set of traffic, or is that really difficult to do?
Maybe. If it's part of a back plane of something that is internet connected,
yeah.
you may be able to see it that way,
But not
otherwise probably not.
Okay.
All right, Well, thank you for all the great questions. We are at time, so I'll turn it over to the next presenter.